We touched on initializer lists in the constructors video, but now we're going to jump a little deeper into the topic. Initializer lists initialize all member variables before any statements in the body can execute and perhaps use the variables. They're introduced with a colon and appear between the argument list and the body. So let's take a look at this. We have a class specification for fraction. We have private member variables. We have an integer that's called numerator and an integer named denominator. Notice these aren't equal to anything here. So these are defined and declared, but not initialized. So if a user were to try to use these, then it would cause problems. We want something to be able to initialize these variables when a new object of this class is created or instantiated. So here we have a constructor. We know it's a constructor because there is no return type. It is named after the class name. And here we see that we're passing in two variables into our constructor. So we automatically know that it is a general constructor since the constructor has more than one parameter inside. And here we are going to have a colon, and this starts off our initializer list, right? So usually we would start at the end of our function, we would use curly braces to indicate, hey, we are about to start a definition of a function. But instead, we're going to say to the compiler, wait a second, I'm going to put a colon here. And remember that numerator that I defined earlier? We're going to set that equal to whatever the user passes in to n. And we're going to separate that by comma. We're going to say, hey, remember that denominator variable, that integer denominator variable that I created earlier, that I specified? Well, I'm going to use that second variable that the user passes in, and we're going to set this denominator equal to that. And now here we have these curly braces at the end because it still has to be in function form. So when you end your initializer list, remember to always end it with either a function, an actual function definition, or these open and closed curly braces indicating that it is a function that just doesn't return or do anything within it. A couple of things to note about initializer list notation. It is a comma separated list of initializer elements. So that initializer behaves like an assignment operator. You can think of this notation or this syntax to be similar to the assignment operator syntax. So here we see this constructor being defined outside of class scope. So we're grabbing our scope operator and our fraction to pull it back in and say, hey, this fraction constructor belongs to the fraction class. A little off topic, but just a reminder. Then we have our two variables that we're passing in. And here we are setting those variables, our class members, equal to those variables. So this works. You can do stuff like this, and people do it. This is the preferred method. So you have the same header, so you have that fraction scope operator and fraction name of your function, your two variables passed in, but this time you have your colon and your comma separated list of initializer elements, I should say. And that way you can kind of separate that initializing activity from your operations or whatever it is that you want to do with those variables, such as, in this case, reduce to the lowest terms. Here is a nifty little diagram of the data flow within an initializer list. So let's take a look at this. We have a class called person. We have a section of private member variables, name, string name, double height, integer weight. And then we have a public section in which we have a person constructor, a general constructor, and we are passing in a string, just like the string that's a name, our name that's a string, and we're calling it a name. Now, this is common practice within C++, is to, when you are creating yourself an initializer list or a constructor, to name whatever the user is passing in a underscore, and then the name of your variable. It means argument, argument name, argument height, argument weight. So we say string, argument name, double, a height, integer, a weight. So then we jump down to this initializer list, pushed down to the next line so that you can see it, although you can do this as well. C++ does not see new lines in your code. So then we start off with a colon, the name of our string variable, so name, and then the initialized, or the value that you want to initialize that name to, and so on and so forth. Here then is the final piece of our initializer list, which is the definition of our function, or an empty definition. Here is another example. One interesting thing I will note is that we have the prototype here in the fraction, and then we have the initializer list here with the definition. So keep that in mind when you are building your initializer list, that if you want to have a definition with them that has meaning apart from just being empty like this one up here, you must put your initializer list with your definition. Here you see that the initializer list is with the definition because it's empty. And here we have a prototype, this example 2, we have a prototype. And then over here in the .cpp file, where we've scoped our fraction function back to our fraction class. And then we have our initializer list right here, and then our non-empty definition of our function. So just keep that in mind. So word of the wise, when using an initializer list with a constructor that is prototyped in the class but defined in a separate CPP file, it is very easy to inadvertently define two functions' bodies, but a function may only have one body. If the function is defined in a source code file, the prototype in the header file should not end with a semicolon. The error shown here will result in multiple definitions diagnostic message, so you just want to avoid compiler errors.